Alright, last page. The proofs. Givens are what is commonly referred to as free points. Make sure you write these bad boys down. These are free points from me to you. Write them down. So we've got given A is congruent to AB is congruent to CB. There we go. There it is. That's going to be given. And what we're trying to do is prove these two triangles congruent. So the first thing they're going to do is they're going to tell us that this side is the same. The next thing they're going to tell us, D is the midpoint of AC. And a lot of you struggle with what to do after that. And the big help is, why would you need to know that D was the midpoint? What does that tell you? Well, if this is the midpoint, then these two sides have to be equal because D is in the middle. That's by the definition of midpoint. That's what they tell you right here. AD is equal to DC. That's the definition of midpoint. Why would you want to know that? Because it gives you two more sides that are congruent. The next thing they say, anytime you see things equal to itself, that's a reflexive property. Reflexive property of congruence. Now, on this one, they give us that third side. BD is equal to BD. So again, we have side, side, side. That proves our two triangles congruent, and we're happy. We're all done. We look up at this next one. Notice we've got two midpoints. They even throw down the definition of midpoint in there. So we look up here. What we do in the definition of midpoint, we claim that those two sides were the same. We're going to do the same thing on this proof. So they want us to prove these two triangles congruent. What they're going to lead off first with is some free points. They lead off with the given. We've got B as the midpoint of AE. Very important. When we're writing this left side, when B is in the middle of AE, you're proving these two sides congruent. So you've got to list it as AB is congruent to BE. All right, you got to use the side that they're talking about by definition of midpoint. Again, they're going to throw another given at us, and they're using CD this time. It's in the middle of CD. So we know that BC and BD are the same. So we line those up. Definition of midpoint. And this is angle. I guess they could not find an angle in Word, so they use that fancy E. This is going to be an angle. So angle ABD is congruent to angle EBC. Now, if you don't understand, one of the best things you can do is you can mark it. Marking it gives you that visual, and it gives you another hint. This is going to be vertical angles. Vertical angles, you don't need that apostrophe, but I use it. Are congruent. All right, vertical angles are congruent. And the last one, how do we prove that side angle side? All right, flipping it over to the last one, the fun one. We've got the parallel lines. Now, the parallel lines, this first one, let's just write down this given. And the next thing they're going to do is they're going to say that UWX is congruent to VYZ. So UWX is congruent to VYZ. So these two angles are congruent. And you're going to go, well, how did they do that? If I give you this same angle, all right, here's those two parallel lines that they're talking about, and here's the transversal that they're talking about. They're telling you that these two angles are congruent. When you just have this image, it's a lot easier to say that these are corresponding angles because you don't have all that extra in there. You'll notice these two lines right here, these are the same as these two lines right here. This transversal down here is the same as ZW, same as that transversal. The only difference is this one doesn't have that extra set of lines, and they don't cut off the edges to make it two triangles. That is the only difference. So they are still corresponding angles. I'm just going to put it here. Corresponding angles are congruent. Same thing down here. They're going to do a given, and they're going to grab another set of corresponding angles by this second set of parallel lines. Corresponding angles are congruent. The last one is a given. The WX is congruent to YZ. And now how do we prove these two triangles congruent? Angle, side, angle. And that's going to be it.